All right, here we go again. So we're going to look at Module 5, which is geometry. So it's your volume, your surface area, and your area of shapes. So it's all about knowing the formulas for a rectangle and a triangle, because if you know those guys, most of the stuff you can answer on your own. So our first question here says, what is the area of the polygon? So remember, a polygon is any closed figure with 3 or more sides. So a triangle is a polygon, a square is a polygon, a rectangle is a polygon, a trapezoid is a polygon. Let's see, a pentagon, a hexagon, a septagon, a decagon, a dodecagon. All those guys are polygons because they have 3 or more sides and they're closed figures. So this particular polygon has 1, 2, 3 sides. This is a triangle. So I need to know the formula for the area of a triangle. The area of a triangle is 1/2 times base times height. I know some of you use the formula of base times height divided by 2. We're saying the same thing because times 1/2 is the same as dividing by 2. So the base of this guy, the base is that flat bottom piece when you put it down on the ground. That is the 9 in this case. So 1/2 times 9. And the height is going to be how tall it is. Don't get fooled by the slanted measurements. The height is straight from the top, straight down to the bottom. So I know 1/2 times 9 is a decimal answer, which I can use a decimal. But I'm going to try to stick with whole numbers here. So I'm going to do 9 times 6 first. So the area of this triangle is the same as 1/2 times 54. And then I have to find half of 54. So oops, I can quickly grab my calculator here. 54, divide that by 2. I'm going to get 27. So the area of this triangle is 27. And then my units, area has square units. I know some of the teachers say area squarea. So 27 centimeters squared would be the total area of this triangle. Next up, we have this polygon, which is a 4-sided figure. We can call a 4-sided figure a quadrilateral. There's 2 ways to solve this question. One way, which I think most of you are going to use, is this 4-sided figure is not a rectangle, not a square. But if I do this, I can turn it into 2 shapes that I can find. I can find the area of the rectangle and add the area of the triangle together to get the area of the shape. Now the thing is to be careful of these measurements. The whole piece here is this 14. This piece is 11, so this part is 11. So the area of this guy would be 8 times 11. So this piece is 88. Triangle is going to be 1/2 times base times height. The base is not 14 and it's also not 11. It's 14 the whole thing, take away the 11. So 14 take away 11 leaves me with 3 centimeters for that piece. So the triangle is 1/2 times 3. Now the height, again, don't get tricked by the slanted. The height is from the top straight down, and opposite sides of rectangles are the same, so it's also 8. I know that half of 8 is 4. 4 times 3 is 12. So the triangle is 12 centimeters squared and the rectangle is 88 centimeters squared. Don't get fooled that you think this looks like a square. It's your teacher's drawing these shapes, so don't go by looks. So if I have 88 and I add 12 to that, so there's 10, I got 100 centimeters squared because area has square units. Now some of you might have looked at this shape and said, well, wait a minute, isn't that a trapezoid? So if you realize that this 4-sided figure, this quadrilateral, is actually called a trapezoid, the area of a trapezoid is equal to 1/2 times the height times the 2 bases added together. So if you recognize this as a trapezoid and you know this formula, it's a little bit quicker to solve it than the pieces, but the pieces always work. So I'm going to take 1/2. The trapezoid is 8 centimeters tall. And then the bases, a lot of you have had questions about how do you know which one's the bases. So if I go back to the triangle, the base was always the flat bottom. Now what makes a trapezoid is that there's 2 sides that are parallel to each other. The 2 sides that are parallel to each other, because they would never intersect, those are the bases. So this total 14 and this total 11. So I would start with, let's see, 14 plus 11, PEMDAS do parentheses first. So I just got to move down a little bit to show my work here. So we had 1/2 times 8 times 14 plus 11 for the area of a trapezoid. So if I add those guys, that would be 25 times 8 times 1/2. So half of 8 is 4. And 4 times 25, 4 quarters, gets you 100 centimeters squared. So for this guy, if you recognize the trapezoid and you are for sure 100% know that formula, easy to do. If not, if you don't recognize the trapezoid or you're not quite sure if you have the formula right, break it down into the rectangle and triangle that makes those shapes. All right, now we're going to go into the 3D dimensions of things, and this one is a rectangular prism. So rectangular prisms with 3D shapes, there were two types of questions they've been giving you. Volume and surface area. So this one says, what's the volume? So maybe this thing is a fish tank, and I want to fill the fish tank with water. If I'm going to fill it to the very tip top, how much water fits inside of it? That's a volume question. Or say this is a cereal box. How much cereal fits inside the entire box? That's a volume question. So for rectangular prisms, the volume is equal to the length times the width times the height. This is only for volume, not for surface area. So to find the volume, the length is 3, the width is 12, and the height is 10. So I can multiply in any order that I want. Here I know that 3 times 12 is 36, and 36 times 10, well, times 10 moves it 10 times bigger, so 360. So area had square units, volume is cubic units. All right, so we have volume is cubic units, while area is square units. This is 360 cubic inches or inches cubed that would fit inside of that shape. So if I have cubes that are 1 inch by 1 inch by 1 inch, 360 of them would fit inside of this rectangular prism. All right, our last question for geometry is, what is the surface area of the rectangular prism? If the length is 9, so I'm going to go through and label these. The length is 9, the width is 11, and the height is 2. So this piece right here is worth 2. So surface area and volume are two different things. Surface area is like if I have a box and I'm going to wrap it as a present. Surface area is covering the surfaces, like how much wrapping paper I need, or if this was a cereal box, how much cardboard I need to actually make the box. It's the area of the surfaces all added together. So the big thing here is realizing which pieces are like pieces. So I'm just going to go through. I want to color code this to help you out here. So the height is worth 2, and we'll say the length is worth 9. Oh, that's not the color I meant to put. All right, so I'm going to look at this and just label the pieces, because all this is 6 different rectangles. If I can find the area of the 6 rectangles, I can find the surface area. So I know that this is 9, that this piece right here is worth 9, this piece is 9, and this piece is also 9, because opposite sides of a rectangle are the same. So knowing that this is 11, this piece is 11, and this is 11, and this is 11, and that is 11. Now the height, if this is worth 2, this piece and this piece have to be the same, because if I'm folding that box, these two lines come together to form one of the corners or edges of the box. So that's 2, this is 2, and if that's 2, this is 2, 2, 2, 2. Again, this piece and this piece have to match up, and same thing with those two pieces there. Now the tricky part is this piece right here. But if you remember, in a rectangular prism, there's 2 of each rectangle. For example, this could be the left side of the box. Here's the right side of the box when I fold it. This is the back of the box. This would be the front of the box. This would be the bottom piece. This would be the top piece. So if this piece is 9 and it's the bottom, this guy's going to fold on top of it. At the top of the box, it's also 9 units, which would then make this 9 units. So remember, in a rectangular prism, they are not squares, they're rectangles. So don't assume they're the same if they're the same, all the dimensions are the same. 11 and 9, they're different. It's a rectangle. So now all I have to do is go through and find the surface areas. So my work is going to be to find the areas of each rectangle first. So this piece is 2 by 11, so this is 22. 9 by 11, that's 99. 9 by 2, so here's 18. So I should have 2 of each one. So here's 2 by 9, here's the other 18. 2 times 11, that's 22. There's the other 22. So this guy must be the 99, right? 9 times 11 is 99. So I have to take these 6 areas, add them together. So you guys know I like doubles facts. So I'm going to add, I'm going to add the doubles together and then add those pieces those 3 pieces, because adding 3 is a lot easier than adding 6. So I got 18. So that piece is 198. This piece would be 36. And here's 44. So 198, 36, and 44. So 4 and 6 makes 10, and 8 would make 18. Here's 10 plus 7, so that's 17. So 278 in its surface area. Area is square units, and they're using units, not inches or centimeters. So units squared. So 278 units squared. So rectangular prism is made up of rectangles, not squares. And there's 2 of each area. And that's it.